Well, good afternoon, everyone. It's noon Eastern Standard Time in the States, so we're going to head and get started. My name is Katrina Searing. I am the Associate Director of the SUNY College of Environmental Science and Forestry's Open Academy, and I'm very glad to be joined today by Daria Getja, our Graduate Assistant in the Open Academy. She has been doing a lot of work for these programs behind the scenes, and very glad to be joined with her. By her. And thank you for the rest of you who are joining us today. It's great to see faces again here, and we'll be glad to reconvene also in March, but really wonderful to have this representation of global sustainability, mass timber minded folks. It's really wonderful to have you all here. So you should be able to see my PowerPoint, and you should be able to see me. And if you need any assistance technically, as I needed at the start, feel free to let us know. Either way, you should be able to see a presenter and the slides at all times. So as we begin today, we like to acknowledge where we stand, that I and others in Onondaga County have the privilege of joining this meeting today from the ancestral homelands of the Onondaga Nation, which is the center of the Six Nations Haudenosaunee Confederacy, who we honor for their many contributions to our world, including the original philosophy and practice of environmental stewardship. So just some general information for our presentation today. The Zoom link that you use today to join is the same for all of our mass timber sessions that will occur next Wednesday and the Wednesday after. Many of you came in muted, and so please do stay that way throughout the presentation so we can get into a really great flow. We will have facilitated questions and answers at the very end. So if they're percolating throughout, feel free to put them in the chat, or you can wait until the end of the conclusion of the presentation to ask them as well. We try to make this as interactive as possible, so feel free, you can unmute and ask your question if that's easier too. This session was approved for continuing education units, both for architects and for engineers. So if you're interested in them, hopefully you've registered the right way for credits, and you've said that to your conference registration as well. And if you are wanting credits or you want to be marked as a participant today, please make sure we can see your full Zoom name. So if you see your tile, you have 3 right dots or an ellipses in the top right corner, and you can click on that to rename yourself. We will be sending certificates of attendance to folks who said they needed them after the session today as well. Also, you'll get another email from me that is a session feedback survey. They will be sent to you after every presentation that you attend, so please respond to those as well. It's really helpful feedback for us, the organizers of the symposium, also for the presenter. So please take just a minute. I think there's 5 questions. It's really quick. Send that on to us as well. And if the presenter has granted permission, and today's presenter has, we will send a PDF of the slide deck and recordings of the presentation after today's session as well. There's our social media links. If you're not already connected with us, please do connect. We're on Facebook at NYS Green Building. We're on Twitter at GB Conference. We're using the hashtag Mass Timber New York and NYSGBC 2023. So here is our agenda for the Mass Timber Symposium. We're very glad to kick it off today with Ona Flindall from Norway, talking about the Halse Tre, Norway's first timber office building designed for disassembly and reuse. And next Wednesday, we'll have Dr. Paul Kremer on building communities above our cities, the rise of hybrid timber vertical extensions. And the Wednesday following, the 22nd, we'll have Sandra Lupian, who's here with us today, on harnessing engagement, research, and policy to build mass timber momentum in Michigan, and in hopes that provides some insights for us in New York. And there's lots of ways to engage. So you are participating in the very first element of the conference and its associated programs, the 4th annual New York State Mass Timber Symposium. We'll also hold the Deep Energy Retrofit Workshop on March 1st. There's both in-person and virtual attendance options there. And then on March 2nd, we kick off the 21st Annual New York State Green Building Conference, where we have both options for in-person and virtual with concurrent sessions, keynote speakers, some really great panels, a student poster competition with prizes, and a clean energy career fair, as we hope to sort of broaden the tent and help others accelerate into the workforce here in clean energy. So really, it's a privilege to welcome you to the 4th annual New York State Mass Timber Symposium. I hope you'll join for all 3 sessions. And of course, this would not be possible without my colleague, Dr. Paul Crivella, faculty member in our Sustainable Resources Management Department, and really our campus lead on sustainable construction and construction management. Paul's a wonderful colleague and a wealth of knowledge, and he's so loved by the students. A couple years ago, he received a Chancellor's Award for teaching, and I certainly know he's taught me a lot. So it's my privilege to welcome Dr. Paul Crivella and to turn it over to him.
Thank you very much, Katrina. Thank you for those kind words. And thank you really for bringing us all back together, both with the virtual sessions and the in-person. Thank you to you and your team for all you've done. It's wonderful to be back this year for the Mass Timber Symposium with our new set of speakers. I was sharing beforehand just how excited I am. I have 2 daughters who are both not studying anything to do with construction, but studying other engineering, like chemical engineering. I sent them both links to this presentation I was so excited about. I said, make sure you're here. So I'm very excited to be able to welcome this year's list of speakers. We're fortunate to have people who followed up on some of the leaders from last year. You recall Ty Farrell and how he provided us an evidence-based approach to designing buildings that can help heal our bodies. Pat Larcom and how he showed mass timber combined with digital design and how that was used to deliver passive house standards. And then the group of Taylor Cabot, Bruno Heim, and Jeff Spiritos, and how they came together to explain how, through a team approach, mass timber could be incorporated into an ecosystem that allows us to meet the standards for affordable housing and increasing housing opportunities for all. I think we're uniquely positioned this year, and I couldn't be more pleased to introduce this year's kickoff speaker, Ona Flindall. Una has been rethinking how the disruption of using mass timber can really allow an opportunity to rethink and incorporate a whole new circular approach to the way we think about the way our buildings are built. Hailing from Oslo, Una and her team at Halse Tre have been leaders in introducing mass timber throughout Norway. Her early efforts included working in the fabrication side as well as the delivery side. So she was very familiar with actually how mass timber was created, produced, and what the economies and aspects of that looked like as the industry grew. More recently, she's been a leader on the explosive growth of mass timber in the use for student housing throughout the country. So I think that's a great example for us to think about, and ensuring that it's done sustainably. So, Una, that's a little informal, but thank you so much for joining us today. And with that, the floor is all yours.
Thank you very much, Paul. Can everyone hear me okay? I'm guessing that is, I'm seeing lots of heads nodding. Let me just get the screen up and going first so we can, and then I can start talking. Let's just see if I can get this up and going. Righto, share that one, and then we do this, and then hopefully it's like magic, and you have that on your screens, I hope. There we are. Good, grand. Hi, everyone. So my name is Ona Flindall. Thank you for the lovely introduction, Paul, and thank you for bringing me across time zones and ponds to be with you. As Paul said, I've been brought on to, and Katrina was saying, I've been brought on to present a specific project today, which is the Hasle Tre project, which roughly translates into Hasle wood. But I'm also going to give you just a brief introduction of who we are, because I think to understand how we work, you need to sort of understand where we come from. I understand there's a Q&A session at the end, so feel free to sort of bombard the chat and store up any questions you have. All right, let's go. So we're a sort of unusual practice in terms of being an architectural office, but we actually have a timber design part to this to the office as well. So we have engineers and carpenters working on staff. So we are architects, but we also design the constructional side of it. And part of the reason why we do that and our history is, as Paul was mentioning, we used to run a CLT factory. So from 2010 to 2015, we ran one of Norway's first CLT production lines. And our office actually started as a design department, if you like, tied to this specific production line. In 2015, we broke out and became an independent design office. But until that point, we were sort of tied directly to the factory, if you like. And that gives us quite a unique position in that we understand the manufacturing process, and that gives us an edge when it comes to both designing rationally and designing for production, sort of cutting out a lot of that communication, if you like, and understanding what the end process is like. And the second part of what we do, which we've been doing since 2010 as well, is to assemble timber buildings. So we have our own assembly team with carpenters on staff, and we make sure that all our architects are on the building site. The saying is you only bleed and cry once, and then hopefully you don't do that same mistake again the second time. So that's an incredibly important learning tool for us as an office, to be able to be on hand to do these assembly jobs ourselves. So I think the largest project we've ever assembled is a 7-story office building here in Oslo. We've sort of gone away from that scale now because we find that we become our own client's competitor. So we're sort of downscaled slightly, but we still do most of our single residency homes and cabins ourselves. And today the office is split between Halse Tre and Oslotre AS, which I curse myself every day that I've named them almost the same, but the Oslotre Tre side works with design of timber, architecture and structural concepts, and Oslotre Tre assembles them on site. So we work with projects in all sorts of scales, really. We've built small, tiny yoga studios and retreats. We've designed the tallest pure CLT structure in Norway. We're working on Australia's tallest timber tower, which is a hybrid structure. So we've worked all over in all scales. But the underlying principle of our office is this statistics. Which I'm sure you all know, and I won't be going on about the sort of overarching climate. I will be going on a little bit about it, but the climate advantage of building in timber. But we are specifically a vision-driven and timber-driven office. So this is, as far as we're concerned, sustainability 101. This is where we should start. We as architects, we don't always have a lot of influence over the processes that we get involved with. We have clients who send their specs to us, but the one thing that we can make a decision on is what material we're willing to work with. And so we singularly only work with timber. I often say that if someone comes to us and asks for a concrete building, we won't know what we're doing. We've never designed a concrete building in our life. And of course, that's also not only tied to the production of timber, but also the manufacture. So the production, the sort of the energy that you use to manufacture materials is much lower for wood-based products, and the more sort of artificial, if you like, the materials become, the more energy they consume. So that's the sort of baseline for it. So it's a very easy, reusable and reshaped material, if you like. It's a form of material that doesn't cost a lot of energy to form and shape. And of course, it's no joke that we're in the climate situation that we're in. And I come from the west coast of Norway, and we are a very, very oil heavy nation, of course. And there's a lot of money being put into ingenious ways of capturing CO2 and putting that back into old oil wells in the North Sea. So we're spending a lot of national money and international money on trying to figure out how we can take CO2 out of the air and put it into something else. But as Dilbert as acutely has observed, that invention has already been made by nature, and it's called a tree. So there is a real potential here for extracting and harvesting CO2 and sticking that into our buildings and removing some of that from the current climate crisis that we're in. The other part of what we do is tied to not the sort of overall environment, if you like, but the personal environment. So the surroundings that you're in as a human being and how that influences your health and well-being. So we do a lot of work with our clients and to try and promote timber as, and not really to promote because it already is, but to try and visualize and show and illustrate how timber has a huge positive effect on us as human beings. To be surrounded by natural materials does something to our psyches and to our physical well-being. And there's a lot of documentation about that now, and that's a huge part of the work that we do as an office and why we choose to work with timber, because we feel and see and can show that this has a direct effect on how we live and how well we as human beings, the overall quality of life. But of course, the underlying principle of specifically the first of those two cases is that if we say that we can take CO2 out of the forest and put it into our buildings and use our cities, if you like, as carbon storage facilities until we sometime in the future hopefully find a better way of dealing with the climate crisis than what we're currently facing, that whole process is very dependent on the fact that that carbon stays locked in within our buildings, that it's not released back out into the atmosphere. And the current situation in Norway, as I believe it is in most other countries, is that there is very little efficient recycling and reuse of timber structures. So, of course, timber has its advantages, but if the end goal or the end result is that you end up with a combustion plant which burns all of the timber that's been demolished from building sites, then you're sort of back at square one. You're going to have to recapture that CO2 and put it back into another building. So the current situation in Norway is that most of our timber waste materials, if you like, from building sites, when demolished, is recycled and downgraded at best, which means that it's chipped up, it's either put back into boards or paper, or it's put into a combustion energy plant. And the statistics on this is quite shocking, really. I think in Norway we're currently decommissioning or burning pretty much as much timber as we're putting into our buildings every year. So we're not winning. And I think in total there's 11 tons of timber waste from building sites in Norway every year. That's equivalent in Norwegian standards to 250,000 single family homes that we burn every year. Those statistics are shocking to us. And of course, that sort of undermines the whole benefit of building and using timber. So the premise for the building that I'm presenting to you is this Hasle Tre, is that we need to find a way of making sure that if we're putting timber into a building, it stays in the building. And if it can't stay in that building anymore, then it's being reused, demounted, and reused in another building in the future. So that's the underlying principle. We need to try and retain the carbon that we've taken out of the atmosphere within building components and reuse them once the building is decommissioned. So when you run a life cycle analysis here in Norway, we usually use a 60-year time limit for a lifetime of a building. We estimate that a building is going to live for 60 years, and we calculate how much energy it's going to cost to build it, how much energy it's going to cost to run it, and then we calculate how much it's going to cost to decommission it. And of course, the first and highest climate cost, if you like, is in production. And by using timber, we're reducing that significantly, and I'll show you some statistics at the end that showcase that. But the second thing, when you're talking about office buildings or office buildings, is that if there's a high turnaround of leaseholders, you have a lot of emissions tied to replacement during its lifetime. So it's quite normal in Norway to have a lease of less than 5 years. If you're changing all the interior decoratings, if you like. If you're changing the plan solution during its lifetime, then that can have a huge impact on the overall climate cost of that building. That's just important to have in mind when we're moving through the rest of the presentation. So the building itself is situated just outside the central zone of Oslo. So I'm not sure how familiar you are with Oslo. It's not a particularly big city. I mean, it's the biggest we have in Norway, but it probably qualifies as a suburb of London. So it's not a very big place. But this is our sort of historic centre with the train station. And this is the hip area. So if you come to Norway, this is where you know to go and hang out with hipsters and drink posh coffee. And then this is just outside what we call Ring 2. So it's we divide the city into circles, if you like. So this is circle 2. But it's very close to the city centre, so it's considered within the city limits. And this is the site itself. It's situated next to this brick building called Vinmonopolet. And I may tell you lots of shocking things in this presentation, but the most shocking thing is probably that this is the old storage building of what is the alcohol monopoly in Norway. So in Norway, all of our alcohol is strong spirits, so wine and spirits and things, is owned by a state-owned enterprise. So they control what's imported and what's sold. And so this is the old storage facility within Oslo. So it's a neighboring building. So it's a very historic context. It has a lot of sort of meaning for people. We built on the neighboring of 2 sites. So this is it's a high school, and we have this other gatehouse. So these 2 gatehouses form a sort of collective square in the center. I'll show you a bit photos of that later on, but this is the old brick monopoly. And of course, we're threading into a historic context here. So it's quite important for us to find a sort of nod or a look of the building that sort of recognized the historic brick tile of the monopoly building. And so we ended up with the timber shingle facade. I actually thought I'd use a slightly different slide for this, so this came as a bit of a surprise. but this is the look of it. The nice thing of it is that it changes colour more individually when it comes to timber cladding, so it becomes sort of more has more of a play in the colours as it sort of ages. And at night, it looks surprisingly similar to the tile facade of the neighbouring building. So I have people coming up to me asking if we've clad our buildings in brick now, and if that's a sort of new trend for the office. So it's clearly got enough similarities to sort of be recognised as that. But moving into the building, so as I said, one thing is to design a building that's specifically designed to be disassembled at the end of life. But another thing is also to recognize that hopefully it won't be disassembled. Like, hopefully, let's try and make the building as adaptable during its lifetime as possible to make sure that we try and keep it in activity as long as possible. So we spent quite a lot of time on the plans to try and make the spaces flexible in terms of adapting to various lease takers during its lifetime, and to be able to change in terms of layout quite easily, and to sort of have a lot of play within the floor plan, if you like, to be able to facilitate the different use. This is the ground floor. So the output of that, the outcome of that, is that we actually have one leaseholder for the entire building. So they took it with I think it's a 10-year lease, so that's quite a long lease, so that's grand. But there needs to be enough flexibility in this to be able to sort of facilitate different uses over time. It's actually saved the children that's moving in, so we think that's a great leaseholder. But this is the spaces are generally quite small. That's the sort of the key find of our sort of analysis, if you like, is that they can open up, but they can also be closed off. So this is the first floor, and you have the sort of auditorium at the very ground floor here. And then you have a sort of visitor space currently, but it can also be a sort of shop facility, if you like. And there's a second lease volume here, or area here. And moving up in the floors again, it's made to be able to be, it's made to be able so that one company, it can lease smaller segments of the floor plan, if you like, and to facilitate for different users, hopefully over time, or hopefully not. Hopefully Save the Children will stay here until that organization no longer exists, which we hope will never be. But the idea here is that you can adapt and change. So there's a grid of 5.5 meters by 5.5 meters, and that's the sort of logic of the space. But you can split them up into more cell-like volumes and or have more open plan, which is what we've sort of gone for now. And then this is the final floor. So there's 2 floors below this. And then also important for us has been that I haven't got any photos of this because it hasn't been installed completely yet, but the roof terrace, the final floor, is a biotope roof. So it's quite common in Norway to have green roofs, but that's quite a low bar, we think, in terms of what you're giving back. So we've introduced more soil and more vegetation. So it's got a higher chance of biodiversity. So there's a lot more sort of plants than in a normal green roof. So the idea being that whatever footprint you take away from the footprint of the building should be lifted up and given back. But you're all here to learn about this structure, so I thought I'd just jump into that. And it's glulam and CLT construction. And it's quite an easy system. It's not a very complex system. Simplifying things has been a sort of golden standard and rule for us, to try and keep it simple, stupid, and to try and sort of make it really easy and understandable and translatable, and therefore also reusable. So the ground structure solution is a post and beam structure. It's designed specifically only take loads. So like to only take pressure. It's not oh Christ, I should have checked these vocabulary for this, but like it's to only take like compression rather than what's the opposite of compression, whatever that is. And that's because we're using timber to timber joints, but I'll be talking a little bit about that later on. But the thing to know about the way that we've used the post and beam system is that we've specifically gone for standard production dimensions. So I'm sure most of you will have seen lots of other timber buildings and maybe also designed other timber buildings. And the way we used to design is that we would perforate these beams to facilitate for technical throughways in the building. We've gone completely away from that really. Now we try not to perforate the beams, because in doing that you both have to fireproof it and therefore expand the dimensions quite significantly. So you're using a lot more materials in round one, and also because you've then perforated the beam, so you've sort of designed the strength load of that beam. So it can only really be used in the same setting again, like it can only really be used in the same situation. But these beams are specifically standard measurements. So that technically they are intact as a raw product at the end of life, so that it can be resold as a beam. It has that direct transferable value. And the same goes for the CLT floors. They're produced to standard dimensions, so that you're using the entire master slab. You're not cutting anything off the slab. You're not taking huge perforations, so you're not wasting any material, and you're also not paying for any sort of openings. So it's the raw element, if you like, the master element. And we're using the innate strength in the CLT slabs to take this span between the two beams, which means that we get this very sort of clean structure. This is the sort of overall concept of the building. This is how simple it gets. And all of the technical logistics is then placed within that throughway, if you like between the two beams. That means that it's an incredibly easy system to understand. It's very easy for the technical designers to sort of design the ventilation systems. We changed the the group of advisors or consultants midway through the final design phase. And because we'd made these really simple, logical sort of transporter routes, if you like, for the technical facilities, that meant that it was very easy to change groups, and they could continue working on this while the rest of the consultants, so the architect and the structural engineers, all that sort of stuff, they could do their work in parallel, so we didn't have to sort of wait for one group to be finished before the other group continued. So it made for a very collaborative process, and actually it really sped up the design phase of the project. So this is sort of in the model, so you can see how that sort of works. And then we've sort of had to sort of take some of the acoustics in the room, and to hide all of these technical channels, we've sort of added an acoustic roofing sort of to the project. And then we've reused, I'll tell you a little bit more about that later on as well, but we've reused acoustic panels at the top end of this. It's a sort of batten system that you'll see photos afterwards. But again, this is where you can see during installation. So this is where they're putting in the fire sprinkling system. So we have that throughout our timber buildings, and then the ventilation shafts that go through this throughway. And then all of the electrical wiring and internet cables and heating and all that goes through the floor. So we're using a subfloor system. It's a producer called Granab. I think they're based in Sweden, and they have this system that's also timber based, and this floor takes both the acoustics requirements, and also because it's a batten system, it's completely disassembled. Like it's very easy to disassemble. It's not attached using any screws or glue or any sort of permanent fixtures, if you like. So it's quite easy to lift up the floorboards and sort of change the layout. And there's the main communication lines have sort of been the channels, if you like, underneath the floor have been laid so that you can quite easily change the floor plan later on. So you're sort of facilitating for a potential floor plan change during the lifetime of the building. So underlying all of this is that if you're going to disassemble something, you need to make sure that whatever you're joining it together with doesn't stay fixed. Like you're not joining it with something that has a permanency that means that you can't separate the materials at the end of life. That's often the key challenge, is that things are stuck too closely together. So it's very difficult to separate them, and then difficult to recycle them. So of course, part of the reason why we're working with timber to timber joints within this building is to reduce the amount of steel that's being used in timber buildings, because that amount of steel isn't insignificant. I mean, we have, I don't know how many screws that we design for when we design joints in floor slabs or in post and beams, and that steel makes the recycling of those timber elements challenging at the end of life, because screws, unless they're specifically designed, are quite difficult to extract. So you need to, at least as sort of minimal, make sure that you use screws that are made to be extracted again, right? The knob head of the screw head of the screw needs to be sort of extra strong, so that the threading doesn't wear down. The screws themselves need to make sure that they won't break. So there's a lot of elements there, and if there's any steel left in that component, then putting that back into a machine to rework that and remodel it for a different and new building will be difficult, because of course those screws will chew up that machinery. So it limits the ability to sort of reuse components. So the solution in this building for us has been to try and replace as much of the steel with timber to timber joints. And we've done that in various different ways. So in the main structure with the post and beams, we've used dowels of beechwood. So this is we ended up with 2 dowels, and it's a very sort of low material usage, but it's an incredibly efficient system, and it turned out to be very efficient on site. So the builders here, they set aside, I think, 8 weeks for assembly, and I think they spent 4 weeks because it went so quickly. They were very skeptical, of course. Here you can see one of our strong, tough builders, doing his best to be as gentle as possible when he's hammering through those dowels. So it's a very quick assembly process. And then, of course, because we're using these master elements in their full format, they're very large elements. And a lot of the process that we've been through as an office working with timber structures over the past 10 years is to learn to trust our modeling. Because timber is a completely prefabricated, machine-produced material, which therefore has potential for an extremely high level of precision. And that's something that you need to learn to trust, and you need to learn to know where the transition is. So the challenges we find is going from concrete foundation to timber. If you mess up there, you've messed up the entire thing. So it needs to be sort of precision. Again, this is millimeter precision. It needs to fit, and it will fit. If you've designed it correctly, if it's milled correctly, it will be like an IKEA furniture, right? The holes will be where they're supposed to be. And to learn to trust that has been a learning curve also for us. But this is a 15-meter span, and it hits 3 columns, and it hits it perfectly. And of course, that reduces time on site as well, because you know once you've leveled out from the foundations, it's literally like IKEA furniture. This is the slab fitting perfectly. Sunny day, there we are, beautiful. And then when this is the first time we've used these X-Fix solutions. This is an invention from, I think it's from Switzerland or Austria, I'm not entirely sure. They have a patent for this solution. It's a sort of birch veneer dovetail locking system that locks the slabs together. Incredibly time efficient. I mean, compared to screwing in, I don't know, 120 screws along that line, you sort of save that with the sledgehammer and a bit of wood. And of course, also at the end of life, then you can potentially, if you want to dismantle this, you just put in a couple of screws and wrench it out, and then you've got your slabs. And the same with the dowels, you just drill them out, and then you've got your construction system back to normal. This is the first time it's used in Scandinavia, I think. So it was a sort of front runner project, and we're learning as we go. So I think we've learned that we need to use some more sort of elegant tools. The picture on the left here is from a wall element, and it carries really, like, you can see the traces of the hammer. So the building is full of these like huge hammer marks from the tools when they were sort of pushing them through, which is an interesting storytelling element, which aesthetically we might have wanted to do that slightly differently. But it was incredibly time efficient, and the builder was very happy with the solution. So this is up in 4 weeks, quick, and everyone's happy. Of course, it's an important thing to say that also, of course, sick leave on building sites that we have in timber are incredibly low. People really enjoy working on them. Everyone's really enthusiastic, and this building has had a lot of press and interest, so people have been really proud to be working on it. And then, of course, the facades are done pretty much by the same principle. So the facade components are all prefabricated, lifted onto site, attached, but can be dismounted in their entirety, so that all of the facade elements can technically be reused if and when. They come prefabricated as these components, and then they're lifted straight on and attached. Yes. And then we clad it afterwards with this shingle. I was just checking to see if I have another slide on that, but I don't think I do. And then we also have used timber windows. So this is a sort of Accoya treated pine. I'm not sure if that's a product that you're familiar with, but it's a sort of chemically enhanced timber for the windows. So it's a very dimension stable. And of course, we've got huge windows, so it's quite important to make sure that we've got control over that. And all of our interior fittings, so all of our interior walls, all of the sort of interior panels are attached using timber nails. So this is these tiny little dots that you can see in the corner here. I can see that we've cheated slightly here because there's a couple of nails, but you get the drift. Attached using these nails, and they shoot in, and as they shoot in, the lignin in the timber melts because of the friction, and that fuses it to the wood. Of course, again, at the end of life, you can drill those out, and then those veneer panels will pop off, and you can use those again in a different project if you want to. Another important part of it is that we try and introduce as much organic materials in our projects as we can. So we're using a cashmere goat hair carpet, and we make sure that all of our surfaces are treated with an open surface treatment. I don't know, diffusion. It's like a moisture. It's not a moisture barrier. It lets moisture through. So it's a sort of breathing surface treatment. So we've used Osmo in this project, but there's also a lot of other different products that you can be used for that. But it's important for us to have responsive surfaces that can help regulate both air quality and in that humidity. And that means that by using low emission materials, by using timber and wool products that regulate the temperature flow and regulate the moisture in the air, and by doing that regulates the heat. We are able to use like a simplified hybrid ventilation system. So in Norway, the standard is a completely closed ventilation system where everything is looped within itself, if you like. So you can't open the windows, but we've been able to open the windows in this project because we've utilized these qualities of these natural materials. And in the same way, we use those materials for sound absorption. So we're using these cork coverings next to the windows as part of the acoustic concept for the building. And what we're trying to do is trying to limit the amount of surfaces that we're covering with non-timber or non-natural materials, if you like. So all of the we're using lots of furnitures that are used using wool. I'll show you some photos, really lovely photos of what the interior architects have done there. But then we've got this cork and we've got the wool and carpet, and that helps to regulate to the acoustics. So we don't have to cover all of the floor, the roof within the office space with acoustic roofing, if you like. Yeah. So here we use, this is the acoustic covering underneath all of the technical services, and we've reused acoustic plates from a project that was pulled down that was owned by the same clients. So we're sort of reusing materials within the project. And that's the other part of what we've done, is not only do we have to try and make sure that everything we knew that we put into a building is like you can disassemble that and reuse that, but also to try and reuse as much as possible that goes into the building. So in this case, we've managed to reuse the ventilation aggregates, and we've reused all of the technical installations, so toilets and sinks and that sort of stuff. We've also reused a lot of other stuff that I haven't got photos of and I couldn't find them quickly, but we've got quite a lot of floor coverings in secondary rooms that are cut-offs and reused. With the sound absorption, and then all of the furnishings in the building is being mostly reused from Save the Children's old furniture. So it's being either upgraded, if you like, or reused in its entirety. And then we've also managed to get these wooden composite toilets. So it's more of a sort of curiosity than a sort of feasible toilet solution. I think it's mostly resin that sort of locks in the timber fibers, but it's a nice gimmick, right? And it's a sort of nice emphasis on the fact that it's a timber building. And then we have a couple of photos of what it looks like at the end. So this is from the staircase looking through to the offices. All of the windows and glass doors, they're also timber framed. I think this is birch that we've used in those. This is the Akoya timber windows. And this is the rooms before they started furnishing them. Again, with the goat hair floors and birch window framings, and you can see the veneer. We were going to use birch veneer as well on the walls, but because of the conflict in Russia, we were unable to get hold of that. So I think in the end it was ash that was used in the veneer. I think in total we've used something like 6 types of timber in the project. So it's a very timber-based project. It's a portfolio. And we try and limit how much we cover stuff up. So this is like, we want the CLT to be visible and to see the material qualities of that, if you like. So it's important for us that you touch a handrail that isn't surface treated. So it's a very organic experience of walking the staircase. And in all of the cuts, be that with door openings or lifts, you see the CLT and its composition within the wall. So you're sort of constantly in dialogue with the material and the material choices. This is the auditorium on the ground floor. This is, I think it's ash that we've used in the floor, yes. And then it's walnut, I think, or cherry. No, cherry, I think we ended up with on these visible lines in the stairs. I don't think you see it so well, but it's a sort of it's a visual marker for people with visual impairments. We were unable to use timber frames on the windows on the first floor. That was a technical issue, no, a cost issue in the end, and was largely due to the fact that they realized a bit late in the process that we were building this on top of a subway station. So there was a lot of more money gone into the foundations for this building than what they'd initially anticipated. And the thing that we had to let go was wooden framed windows on the first floor. So I'm sorry, it's not a complete timber interior, but we can't win all of the battles. So this is some of the interior furnishings that have been added. Some of this is reused from old furnishings that the Save the Children had. So I think both this table and actually the cushioning on the sideboards is a reuse project. And then they've added these acoustic boards to sort of give a soundproofing. And then we have wool in these partition walls that are used within the landscape of the office building to batten some of the sound down. I would like to have shown you more photos of the interior, but we've just had the photographer up to take photos. This building opened. We had the formal opening of this building 2 weeks ago, and the photographer was there last week to take sort of final shots of the interior and people and stuff. But we need to have those approved by both Save the Children and the owners of the building before we can publish them. So I'm sorry I can't show you any more photos of sort of the office landscape in use. But this is the opening ceremony. This is the mayor of Oslo when she was opening it. And we're already getting lots of positive feedback from Save the Children. They are saying that people who previously didn't necessarily come into the office are now coming into the office more already because they enjoy the working environment so much. So it's a very appreciative client in the end for us. And this is what it looks like from the square. So looking from the Monopoly building and back onto the main entrance of the building, which is behind this. And of course, right now the facade is looking really new and shiny, but it will age over time. So you'll get a grey patina developing as it weathers. But the interesting slide at the end, and this is my final slide, and then I'll open up for questions. And I'm actually ahead of time for once, which is fairly unique. But this is the sort of CO2 calculations looking at this building up against the reference building. So the reference conventional concrete and steel building is the orange, and then our building is the dark, the black column. And I've tried to translate a couple of the categories here for you, but the foundations, we're quite low on foundations. Of course, timber buildings, as you know, are quite light structures, so they require less foundational work. The structural system itself, of course, being timber-based, is naturally much lower in CO2, and the outer walls the same. You'll see that the glass and the facades is much higher. That's partly because we've gone for a lot more glass than what a sort of reference building would contain, and we do that both because we want to use and give natural light to the working spaces, and that means that we have these incredibly airy office spaces, but also because when you're designing these timber buildings, we want a very quick fire, for instance. So it's actually part of our fire concepts for these buildings that you want a quickly developing fire, because that burns very fast and very hot. And that will mean that the surface of the timber turns to coal and limits the progression of the fire through the structure. So we always work with really large surface openings. And that's a win-win situation for us, but it does cost us a bit more when it comes to the CO2 emission calculations. And then there's the flooring at the end, and then of course I add the stair because it's rather funny. But that is actually me on 42 minutes. That's impressive. I'm quite pleased with myself. But hopefully that leaves us a bit more time for a healthy discussion. So yeah, I'm not sure. Would you, Katrina, would you prefer me to stop sharing? Is that the best way to go forward now, or
maybe not, just in case friends have questions about your presentation or one of your slides? Thank you very much. That was really awesome to see and to learn more about. There was some chat going the whole time, and mostly like, wow, that's cool, but there were a few questions.
Good.
And the first is from Nicolette. Nicolette, would you like to ask your question?
Oh, sure. I was just wondering if there were any special, I think you might have answered it in the course of the presentation, but does your firm do any finishes or treatments to the wood or leave it exposed to weather naturally on the interiors and exteriors?
Yeah, so I think I had a slide on what we do to the interiors. Let's see, we've used this Osmo, it's called. That's a product that we've used quite a lot. It's a hard wax oil-based product, and it's the main quality of this is that you can add pigments and that you can that it retains moisture transmission. So it's quite important for us to not cover our surfaces with like a lacquer, like is that the word? Like a sort of hard surface that doesn't breathe. So to get all of the benefits of being in a timber building, it's important that the material retains its ability to respond to the moisture in the air, right? To absorb moisture from the air. That's one of the key components. So we never want to, unless we have to. We've worked a lot with toilets actually, or like bathrooms and shower rooms. So we have showers and bathtubs and sinks in wood, and then you of course have to treat it with something to try and retain some of the quality of the wood, so you need a harder surface. But overall we try and not use something that locks the moisture out of we want the responsiveness of the material. Externally we haven't used anything. So the cladding itself will weather and it will wear off. So that's part of the appeal, if you like, of the cladding itself, is that it will change color over the seasons. Oh yeah, I forgot to add, in the interior we add a white pigment, so it's sort of slightly treated. Let me see if I can find a photo of that. I'm not sure if you can see it very well. You can see there's some sort of runoff, so we weren't very pleased with the surface treatment, the people who did the surface treatment. So this is the sort of stuff that really annoys us, but probably no one will ever notice. But it is surface treated after it's been assembled with a sort of white pigment in it, and that's to try and counter the yellowing of the wood. And in this case, because we also work with so many different types of wood, it was important for us to sort of down tone slightly the tones of the wood, if you like. But we but that's also a client preference. I think we might have gone for a bit of a stronger contrast if the dialogue had gone differently in terms of what their wishes were for the interior.
And Bruce had asked if that interior treatment would allow it to reduce sort of fingerprint stains and stuff as well. Would that stain or that coating prevent fingerprints on the inside?
Yes and no. I mean, it will. I mean, no. Technically, I mean, it'd be easier to wash slightly, but part of being in a timber building is that it will pattern. You'll get a patterner, right? Of course, you can sand it down, you can repaint it, or you can wash it or whatever to sort of diminish that. But one of my colleagues at the Oslo School of Architecture did her PhD quite recently on what she calls the lovability of timber. And the idea being that timber, because it has this ability to retain stories, right? I don't know, in Norway at least, timber is very ingrained in the national identity. So most of us have either owned, or their family has owned, or some of their friends own a cabin somewhere that's been handed down through generations, where the stairs are slightly bent at the middle because you can tell how many people have walked on those stairs over time. Where the foot threshold of the door is like worn down in the middle because everyone's walked there over the years. And most of us have grown up in buildings with timber exposed in the interior, and you've scratched in both yourself and your sister. Maybe you've even drawn something on the wall that still retains some of that story, right? And that sort of storytelling ability. And timber weathers with style, like it weathers with, or it ages with style, and it ages with elegance. And that's a very different surface to age than, say, a gypsum surface, where if you bump into a gypsum surface, it's broken and you need to fix it. Like there's a completely different way of thinking about a timber surface, which is much more robust. So we see in Norway now most kindergartens and schools are built in timber precisely because of that. It's a very robust surface. It can handle rough use, and it actually becomes more beautiful, really, the more you use it. So yes, it will mitigate some of that sort of surface treatment, if you like, but overall we actually would like to say that that's a storytelling element that actually would benefit the building in the long run.
Well, thank you. I certainly agree. Bruce had another question about using wool in the interior, which I thought was super cool. Bruce, would you like to ask?
I was wondering if there's any danger of infestation by moths, the moths that attack my sweaters in the drawer.
I'd like to say no, but I don't actually know the answer to that. I think that would be a producer question, like that, where you'd almost have to ask them. I mean, I think this is it's a goat hair product, so I don't know how moths respond to hair more than wool, if you like, but that would probably be interesting to find out, and maybe they treat it with something. I'm not entirely sure. I know we've had some issues with wool insulation in the past, like where that's been used in walls and that sort of stuff, and that's been attacked both by mites, but also I think by mice specifically. So working with natural materials always has a sort of, I think, a potential consequence in something like that. But I think I mean, you still have to clean this. It's not a self-cleaning floor. So I'm guessing that with good maintenance and the fact that there's so much light, which of course kills off mothballs and that sort of stuff, then that could potentially mitigate against that. But I would refer you to the producer to get like a more satisfying answer on that.
And for folks who have to log off by 1, just thank you very much for being with us today. We have a couple more questions that we're going to get to, but please remember there are 2 more sessions for the Mass Timber Symposium next Wednesday and the following Wednesday. So if you do have to log off, just thank you for being here, and look forward to seeing you next week. But Jody Smits-Anderson had a related question about pests. Jody, are you able to ask?
Yes. Can you hear me okay?
Yeah.
Great. So I just had a curiosity. We've talked about timber use in the past, and we have woodpeckers in the upper Northeast in the US, and we also have carpenter bees, which sometimes really like wood buildings. Do you have the same in Norway, and how do you address that?
We do have woodpeckers. I've never experienced that they've actually attacked a sort of healthy building. Mostly woodpeckers will be boring through wood to get to insects behind the wood. So they usually attack wood that's somehow damaged by rot or moisture. Both of those in most cases. So that's really a maintenance question, really, in terms of like how well can you keep the facade up and going. In terms of the insects, that is a sort of discussion, but we haven't really seen that as a problem. I mean, we've been cladding buildings in Norway now in timber since the 90s, really, the early 90s, in a sort of industrial sense. Of course, we have timber buildings that have been clad in timber for a lot longer than that. But it's not really an issue so much like in terms of the exterior of the buildings. We do have I'm not sure if I'm talking about the right insect, but there's a whole catalogue of them. So there's a couple of insects that more attack like the interior of buildings, and they sort of bore into the wood, and then they sort of produce this like flower, almost like we call it flour, I don't know, that comes out of the wood. And that's they also mostly they are temperature dependent, so that they won't attack a building that's acclimatized, if you like, or that's inhabited. So that hasn't really been an issue for us here. But I know there's one valley in Norway where they have some pesty insects, and there's some developers there who've been very cautious. But we build timber buildings all over Norway as single residency homes anyway, so this is just scaling it up slightly. So so we haven't had any significant problems there, no.
That's great. I know termites, I think that's what you were mentioning. Termites can create that kind of flower. And I know termites in the US with climate change are moving further north over time.
I was actually in a meeting, that's an ant actually, so that's a slightly different thing again. but a lot of the ant situation, which I had a meeting with a developer here the other day who raised that issue, and we've yet to see termites cross the German border, if you like. So I think it's a while before it gets up to Norway. But I think the key with termites is often how the building meets the ground, because they're sort of dependent on a way in. So I think there's a lot that can be sort of solved in how you sort of specifically meet ground level there. So I'm looking forward to that challenge whenever that comes.
Can you share a little bit more also about the document designed for owners for future reuse?
Yes. So we've made like a catalogue for the owners of this building in terms of how they would go about disassembling it. So that's done in collaboration with us, but also with the builders. So that's specifically like a manual that's handed over, showing how you would have to, like, which parts have to come off when for the building not to fall apart, basically, and which sort of sequence that would happen in. Yeah, so that's part of our sort of handoff, if you like, at the end.
Okay, great. Liz also asked about reconfiguring. Liz, are you able to ask your question?
I am. Can you hear me?
Yes, we can.
Okay. Yeah, I was wondering, because we're a glue lamp manufacturer, and we sometimes get photos in from job sites where other trades have drilled through beams or, there's notches made. And I was wondering if there was a specific, clause in a lease for a client where they can only do so much reconfiguring, or what the limitations were on that to preserve the reusability of the beams.
Yeah, I mean, I think the biggest issue we had here was actually use of sealants. So we actually had to have like a meeting with all the contractors working on the building and say, look, you can't, because that sort of negates the entire purpose of the building if you're putting in lots of sort of glue stuff in all of the joints, right? So that was the sort of the biggest issue we had. In Norway, we work in BIM models all the time. So I think a sort of premise for getting a good timber building up and going is actually that all of the consultants are working on the same model, and that you've sort of thought through all of the different sort of logistics and technical joints and transitions before you get onto site. So most of the thinking about how this building is going to be put together has been done before you start. And then, of course, I think key to the success of this project is that we've had a builder on board that's understood the concept of what we're trying to do, and they've been interested in doing that, like getting that done properly. So they, I mean, you can't, in all of our buildings, you can't perforate a beam without that causing some sort of problem. So that's really a no-no. And if any sort of changes that has to do with the sort of structural strength of the building, then that needs to be approved by the engineers during the design, the building process. So we will get requests sometimes, not in this building, because this building is, of course, a sort of 1 in a million. But generally, we would get a request then from the builders on site saying, look, we see that we need to perforate this beam at this spot. Can we do that? And how big can we take that? Can we make the hole, basically? So that's a typical sort of request that would get from site. But here, all of the technical solutions were independent of the structural system.
And Sean, I think Sean is still with us. Sean had a question about fast flame movement. Sean, are you able to ask your question?
You had mentioned earlier about wanting flames to move quickly through the building, and I'm just curious because that seems counterintuitive to trying to mitigate flame spread within the building, especially to allow for egress to happen quickly. So if you could elaborate a little more on that philosophy of making them char fast enough so that it doesn't damage the interior grain versus how you balance that against the egress challenges and requirements for a building.
Yeah, I'm not sure what the egress requirements would be. I don't understand that term. So, but
how fast people can evacuate.
Okay, yeah, right. Okay. So basically, the way we deal with fire in timber buildings in Norway is there's a couple of sort of underlying things that are the same for Norwegian buildings, regardless of whether it's timber and concrete, and that varies a lot from different countries. So in Norway, it's important to know that our fire regulations mean that if you have a building that's above 3 stories, I think, you have to have a lift. There's a lift requirement, and as soon as there's a lift requirement, there's a sprinkling requirement. So all buildings that have a lift need to be sprinkled. So the fire extinguishing system is like a water-based system. Or a steam or whatever based system, and that means that it's not a cost driver in a project. So I think that's for a lot of countries that's not the case, right? So you end up with a lot of costs tied to fire safety and fire regulations. So I just want to say that because I know that that's often an issue. But in terms of how we, in all of our buildings, we do what we call a full fire analysis, like a review of how a fire would develop within these spaces and how it would transport itself through the building. And the general rule for us is that you want a quick fire because you want the surface of the timber to char. That's basically the sort of principle of it, if you like. And if it chars quickly, it will extinguish itself. That's basically the sort of premise of the analysis. And I'm not a fire expert, so that someone else will be able to answer that more sort of substantially for you. But that's the sort of key of having big window openings, is that you can get a lot of oxygen in, you can get a very fastly developing fire. So what we find is that we often see a difference between the steel and concrete buildings, where steel performs quite unpredictably when it comes to fire in terms of heat. So we've had quite a few quite ugly fires in Norway where steel structures have collapsed. So we're trying to, of course, with the timber building, the charring is fairly predictable in terms of how it will char. Of course, I'm not looking forward to the first day when a big multi-story timber building burns, because I'm sure all of our hypotheses will be tested daily, but until now, that's the working theory, and all of our tests that we've done in Trondheim and Antenu, and all of our sort of research institutions in Norway, where they model and then test and burn big buildings to see how they burn, underbuild this. So it's about sort of you want the charring to be quick. That's as much as I can sort of give you of a suitable explanation. I'm not sure if that's sufficient for you, but if you still have questions on that, I could probably refer you on to some people who know the topic of fire a bit better than I do.
Thank you. And I think that's brought us to our last question. And Ona, I just want to let you know that your Teams file is up on our screen, that we can see that. So if you...
Oh, I'm sorry. Yeah.
No, that's fine. I just wanted you to know that that was out there.
Yes.
Our last question is from N Fector, I believe. Are you able to unmute and ask? Yeah.
Hello. Am
Hi.
I coming through?
You are.
Hey, I'm Noah. You got my last name perfectly. Thank you. Yeah, the question was if you had any other examples of workarounds for like mechanical enclosure and floor raceway, like in the Halse project. I was really fascinated with the way that workaround works, but you might not always have the ability to create a gap between two beams, or I don't know, the design willingness from structural. So I'm wondering what else worked, because this was a sticking point in the class that I took on mass timber just 2 years ago, was workarounds between structural and mechanical.
We've done 2 office buildings in parallel this year, this one and another one, and the other one is a bit more sort of conventional. We do perforate the beams there, but we try and limit that to set areas. I think what we were quite sort of concerned with as an office, if you like, is that we need to solve the structure early enough on in the process. So a lot of architectural offices, at least here in Norway, will design something and then they'll send it to the structural engineers. But we work with the structural engineers from day one. So, and we have our own. So because we need to solve exactly those sort of issues, like how can we find a logic here that works, that's it's easily understandable, if you like, but that has a sort of internal logic. So we spend quite a lot of time actually on figuring out what's the communication system, if you like, within the building. But we work quite a lot right now on how to solve all of this, like how to solve the floor slab situation, because that's where all the magic happens, really. And so we have actually we've done some cross-disciplinary workshops. So we had one now in January to look at how can we find different floor solutions, and we're working with a lot of cassette sort of solutions where you can take a lot of those sort of communications through the floor slabs, but that are sort of pre-designed as well, but not a CLT floor. I think we're probably going to end up with a solution that isn't CLT based, if I'm going to be honest. Like that's probably where we'll end up, because it's a very sort of thick, it becomes quite a thick floor, flooring, but there are we're looking at a lot of different solutions for this floor. So I'm not surprised that that's a sort of continuing question, because that's it is one of the key challenges to solve in every project, really. But to get people on board early enough is key, and also to make sure that everyone is working in BIM. So all of the disciplines and all of the consultants are working to solve stuff in this digital sort of format, if you like, gives the projects an edge. And I think that's been key for us, and when we've developed all of our projects. So I hope that sort of answers your question.
Well, I think it does. Thank you very much, Ona. That was a fantastic presentation. We covered a lot of ground in the Q&A too, everything from pests to fires to mechanical and engineering systems. So thank you very much. I'm going to take back over the screen share. just to close us out for today. And there's lots of congratulations and thank yous in the chats as well. Fantastic presentation. So thank you for kicking off the 4th annual New York State Mass Timber Symposium with a great project. For those of you attending, please remember to join us next Wednesday for Dr. Paul Krummer's presentation on building communities above our cities, the rise of hybrid timber vertical extensions. And also the following Wednesday for Sandra Lupin's presentation from Michigan State University, all happening at 12 p.m. Eastern Standard Time. And if you've registered for professional credits, we will be sending out those for this presentation for PDHs and LUs. And if you registered to receive credits, we'll be sending you a certificate of attendance as well. So you can self-report to whatever accrediting body makes the most sense for you. And you'll also be getting a survey about today's presentation. So please be sure to complete that as well. And if you have any questions, you can reach me and others at nysgreenbuilding@gmail.com. And we'll do the very best to get back to you quickly. And I neglected to say at the onset here, you know, that being together in person is wonderful, but there are benefits to this hybrid format. And so we're able through this process to gather folks from 6 different countries and 14 states. People representing those places are participating in this Mass Timber Symposium. So very grateful to have that geographic diversity. And thank you to Ona for adding a whole country for us today. Thank you very much. And look forward to seeing you all back here next Wednesday at noon. Thank you all.
Nice to meet you.
You as well. Thanks, everyone. See you soon.